Okay, so this is actually take 2 because I made a mistake and I had to have another go. So anyway, rereading the question, using the equations for the Doppler effect, equations plural, that's the Doppler effect equation, f dash equals f, and modifying f by multiplying it by the velocity of the wave, divided by velocity of the wave plus or minus the velocity of the source. So remember, the source is moving and giving off waves at a particular frequency, and the frequency is modified, or the wavelength is modified depending how you look at it. And literally depending how you look at it, whether your object is moving, the source is moving away relative to the observer or towards. But anyway, carrying on with the question, show that V source divided by C equals change in wavelength over wavelength, where C is the speed of light, delta wavelength is the difference between the wavelength from the star and wavelength measured in the laboratory, and velocity of source is the speed of the star relative to the Earth. Okay, so as I said, the equations, I gave you one of them. We've also got the wave equation, V equals F lambda. That's very useful in this case, and we could rewrite a little equation for the change in wavelength here. They've told us it's the difference between wavelength from the star and the wavelength is measured in the laboratory, so we could write it like this: delta wavelength is equal to wavelength dash minus wavelength. So these are the three equations. We can combine these in different ways to achieve what we're aiming for, which is this equation over here. And we then use that equation in a later question. So, first thing to do, I think, is to consider, we've got plus or minus here, we want to get it the right way. So we're dealing with we're the observer on Earth here, and the star is moving away from us. That's going to stretch out the wavelengths, so wavelength dash is going to be greater than, can't draw everybody. Anyway, wavelength dash is going to be greater than wavelength, and from the wave equation, if the wavelength is increasing, the frequency must decrease. That means this term in the equation has to be less than 1. Otherwise it doesn't modify that frequency to produce a lower frequency, which is what we'd expect if it's going down. Okay, so anyway, how do we make that, for that term to be less than 1? We have to make this a plus, because the bottom number has to be greater than the top number for it to be less than 1. So we know we're dealing with plus in the equation. Anyway, so that's all of that. That's all the big build-up. How are we going to use it? I think a good thing to do is start off with the Doppler effect equation, and then we can actually write two wave equations. I'll see if we've got enough space just over the side here. We can do V equals F lambda for the normal frequency of the normal wave, and we can also do V equals F dash lambda dash for the modified frequency and wavelengths. But V is going to be the same. Remember, V equals C. Okay, so we can perform substitutions for V equals C and for our two equations above into our Doppler effect equation, and that's going to give us something to go from. So F dash is equal to V divided by the wavelength, or C divided by the wavelength. So C over, this is the modified wavelength, should equal C over our original wavelength multiplied by the velocity of the wave, which is actually C, but I'll just leave it there for now, divided by V W plus, we worked out plus the velocity of the source. Okay, so if we divide both sides by C, this is the mistake I made earlier. I was actually treating these two terms as added together rather than multiplied together, so I started dividing extra parts of it by C. In any case, we can divide both sides by C, and we can also do I'll do this bit by bit. So 1 over wavelength dash equals 1 over wavelength times by VW over VW plus Vs. So we can actually take the inverse of both sides of this, because there's no different parts that are going on here except for basically one big fraction on one side and one fraction on the other. So wavelength dash equals wavelength times by Vw plus Vs divided by Vw. Awesome. So now we drew this other equation here, and we can kind of use that to help us along. We know that wavelength dash is equal to the change in wavelength plus the wavelength. So we can substitute that in into our equation. Hang on one moment. No, that should be fine. So we're going to substitute that part there into our equation, and I'm just going to go change colour so that we can see what's going on. That was wavelength, change in wavelength plus the new wavelength gives us the wavelength dash. So change in wavelength plus the is it plus the new wavelength or plus the no, okay, good, just double checking, equals wavelength times by Vw, which is C, plus wavelength times by Vs, velocity of the source, and divide all of that by velocity of which is C. Okay, so we can multiply C across there, so we can get change in wavelength times C plus wavelength times C equals wavelength times C plus change in wavelength times Vs. And we can then minus from both sides that common term, so we end up with delta wavelength C equals wavelength Vs. And I think you can see where this is already going. We want to get we're going to divide both sides by Vs, so it cancels there, and divide both sides by C, so it cancels there, and that leaves us with, in a nice colour again, delta wavelength over Vs equals the original wavelength divided by C. I'll just go back all the way back up to the top to have a look, and they've got it in the inverse way. So velocity of the source over C. Oh, okay. they've multiplied it out a different way. What did I do? Doesn't matter, but I've done it correctly, except that we don't want it in quite that form. We want to divide both sides by the wavelength, and multiply both sides by Vs. Okay, so I've just rearranged the wrong part, and I'm rearranging back again. That's fine. And so the wavelength gets rid of that, and we're left finally with change in wavelength over the wavelength equals Vs over C, and that is what we were looking for up the top. There we go. Whew. Except once again we've written this part on the left hand side and that part on the right hand side, but it's all good.